This video is on reflections, one of the three rigid transformations. For reflection, the simpler term is to flip. We'll be taking this a hexagon and flipping it across this line of symmetry. Now when you do a reflection, there's a few things to remember. The line of symmetry is always perpendicular to the line that connects the pre-image to its image. So if this is horizontal, I'll be moving it vertically. The line of symmetry will also bisect this connecting point between the pre-image and the image, meaning whatever you have above it, it'll be the same number below. So to begin, this corner is currently 2 units above the line of symmetry. When I reflect it, it'll be 2 units below. Over here is also 2 units up, so 2 units below. This corner, 4 units above, becomes 4 units below. This vertex is 6 units above, becomes 6 units below. And so on. And I keep doing this across the figure until I've caught all 6 vertices. I can then draw it. And once I have it drawn, I want to point out a few things. If you connect any pre-image to image, you're going to notice that it is perpendicular to the line of symmetry. If this new line is vertical and the original was horizontal, that's perpendicular. They form a right angle. In addition, the figure was 2 units above, and now it's 2 units below. This segment here is equal to this segment here, meaning the original segment is bisected by the line of symmetry. Just like this one over here, if I was to connect 4 units above is equal to the 4 units below. They're also at a right angle. So again, it's perpendicular to the line of symmetry, and it's bisected by the line of symmetry. Now let's look at a little bit harder example. This next example has a line of symmetry that's not horizontal. Instead, this one is diagonal. Now if I look at the original slope here, this one goes down 1 and over 1. This slope is -1. To find where I'm going to go with my reflection, I'm going to take the opposite reciprocal. I'm going to find the perpendicular line to this original line of symmetry. If I flip -1 and change the sign, I will get that the perpendicular slope is +1. So when I do this, I'm going to take each corner, each vertex of this trapezoid, and I'm going to reflect it using a slope of +1. I'll count how many triangles it takes to get there. So this is 1, 2, 3, 4, 5 triangles to get to the line of symmetry, which means 5 more. 1, 2, 3, 4, 5 takes me to where the image is. Up top, this one is 1, 2, 3, 4 triangles away, which means 4 more. 1, 2, 3, 4 tells me where the image ends up. Up top, 1, 2, 3, 4, 5, 6, and 6 more. 1, 2, 3, 4, 5, 6. Again, tell me where we end up. Now this last one's a little bit tougher. 1, 2, 3, 4, 5, 6, and a half. So here's half, 1 and a half, 2 and a half, 3 and a half, 4 and a half, 5 and a half, 6 and a half. That's where that corner ends up. So if we connect, this will be our image. And again, I want to point out what we're seeing. If we connect any point, which will be the pre-image, to its new point, which is the image, we're going to notice that this line is perpendicular to the original because this slope is +1, this slope is -1. Right, those are opposite reciprocal slopes, which means that the line segments are perpendicular, and the segments are equal length. This is a triangle that has dimensions of 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, just like this one is also down 5 and over 5. If we were to use Pythagorean theorem, we would find that these lengths are equal. And we can do that for all of the corresponding points. Now when you connect these all, you also will see something else. You're going to notice that all of these connecting lines are also parallel to each other. So all 4 of those lines that connect image to pre-image are parallel. Now here's one. Go ahead, if you can, draw this, pause the video, and then restart it when you think you know where the reflection is going to be to check your answer. I'll give you a minute to get caught up. All right, hopefully you've had a chance to try this one on your own. Currently, this line has a slope of 3. It goes down 3 and over 1, or up 3 and 1 to the right. So right now, this line has a slope of 3. When I do my reflection, I'm going to use the perpendicular slope, which is the opposite reciprocal. That's going to be negative 1/3. So I'll use negative 1/3 slope triangles to find out where those points are going to end up. This one, if we go down 1 and over 3, it takes one triangle to hit the line of symmetry. One more will tell me where the image ends up. Up top, this one is 1, 2, 3. Down 1 and 1, 2, 3. It takes 2 triangles. So if we go 2 triangles more, that's where that point ends up. And then lastly, down 1 over 1, 2, 3. Down 1 over 1, 2, 3. Down 1 over 1, 2, 3. It took 3 triangles. So here's 1, 2, 3 more triangles, and that's going to tell me where it ends up. So connect. And there's the new triangle. There are a few ways you can check if you're right. If you connect any of the images to the pre-images, you should see that they're perpendicular to the line of symmetry, and you should see that they're bisected by the line of symmetry, and you should see that they're parallel to each other. If you connect them and you realize that they're not parallel to each other or they're not truly bisected, then that tells you that your reflection's off. You need to go back and check it. Now let's look at one more type of reflection. And in the next problem, I have done the reflection already. What I need to find instead is the line of symmetry. So to find the line of symmetry, what you're going to do is connect any pre-image to image. So I'm going to connect these 2 points and those 2 points. To find the equation of the line of reflection, what I'll be doing is finding the slope of the original connecting lines. So for instance, these would go up 1, 2, 3, 4, 5, 6, and over 2, which can be reduced to 3, or 3 over 1. And then to find the equation of the line of symmetry, it's going to be the opposite reciprocal. So perpendicular slope to this would be negative 1/3. Another thing I need to do is find one of the points in the middle. Something that is on the line of symmetry would be somewhere in the middle of each of these connecting segments. So if this goes down 6 and over 2, half of that would be 3 and 1. So again, down 3 over 1, down 3 over 1 tells me this is the middle point. So from that middle point, which I'll label as negative 3, 0, I'm going to travel with the slope of negative 1/3. That means down 1 and 3 to the right, or up 1 and 3 to the left. This is going to be my line of symmetry. To find the equation of that line of symmetry, I'm going to use point slope form, or because it has a nice y-intercept, I can use slope intercept form. So I can either say because it has a nice y-intercept of 0, negative 1, and I know the perpendicular slope is negative 1/3, I can write in the form y equals mx plus b, and say it's y equals negative 1/3 x minus 1. Now it's not always going to have a nice y-intercept. If it doesn't, we would instead use point slope form. Point slope would look like this. Y equals m quantity x minus x1 plus y1. In which case you would use one of those clean points that were the middle points on your connecting lines, and you would get this. Minus a negative 3 becomes plus 3, and then plus 0 we would leave off. Now these equations may look different, but if you were to simplify and distribute this one, you would get something that's equivalent to the original equation. So both of these are equivalent. They look different, but they really are the same. All right, so I've got a second example now. I would like for you to try drawing this at home, work it out, find the line of symmetry, find the equation of that line of symmetry, and then resume the video to check your answer. I'll give you a minute again. so for this problem, hopefully we've worked it out, I'm going to connect every pre-image to image. I need to find which ones have nice clean coordinates. All right, looking at it, I'm going to find the slope of one of these lines. I'm going to start with this one. This line goes down 1, 2, and over 1, 2, 3, 4. So this current slope is negative 2/4, so reduce that to negative 1/2. Now if I use any of the other lines, I'll see the same thing. It goes down 1 over 2, down 1 over 2, or this one, down 1 and over 2. They're all parallel to each other, so they'll all have that same slope. Perpendicular to this, try again, perpendicular to this would be to flip it, reciprocal to be 2, change sign becomes positive 2. Now I need to find some point in the middle, so something that is on the, where the line symmetry bisects. So if this goes down 2 and over 4, half of that would be to go down 1 and over 2. So I could use this point right there as the known point. That point is negative 1, 1. From this point, I'm going to travel with a slope of 2, meaning I go up 2, 1 to the right, up 2, 1 to the right, or I can go down 2 and 1 to the left. This is going to be my line of symmetry. And my equation could be in one of two forms. I do have a nice clean y-intercept. The y-intercept is 0, 3. So I can choose. Do I want to write it in slope-intercept form, where the slope is 2, and we have 0, 3 as the y-intercept? So the equation would be this. Or I can use the point that was on the line of symmetry, that was not the y-intercept, put it in point-slope form, and I'll have this instead. Minus and negative 1 becomes plus 1, and then the other plus 1. Again, the equations may look different, but they're equivalent. If you distribute 2x plus 2, plus 1 more becomes y equals 2x plus 3. I hope this video helps you, and thank you for watching.